Good evening, students. Um, Now, in this video, we are going to see about composite materials. Before that, we have studied about metals, non-ferrous metals, plastics, polymers. Most of the materials we have already studied. In this video, we are going to see a new materials, that is composite materials. So what is, before going to define the composites, we have to know about the types of metals. So the metals are mainly classified as alloys, ceramics, glasses, and natural materials like natural fibers. So in this video, we are going to see about composites. So mainly composites are classified as metal matrix composites, natural composites, etc. So before going to enter the depth of the topic, we have to know about what is meant by composite. So composite is mainly defined as two or more chemically distinct materials, which when combined have improved properties over the individual materials. So when you combine two materials, so individual properties will be combined, and the properties of each materials will uh, demand. It will incorporate both properties of materials. So the composite is mainly consist of one or two or more materials combined together to get the combined properties of each materials. So that is composite. Then mainly the purpose of making the composites are it have light in weight, it have more strength to weight ratio. So it has more strength and stiffness to weight ratio. So composites are widely compared with materials like aluminum. It will have more strength and light in weight. And also composites will have high fatigue properties. What is meant by fatigue properties? It is ability to withstand the repeating cycling load. So composites are having more fatigue properties than metals. Then composites will have more corrosion resistance than steel. Then it will have possible to achieve combinations of properties not attainable with metals, ceramics, or polymers alone. So mainly there are two phases in the composites. One is matrix phase, that is primary phase, which the secondary phase is embedded. Then second one is reinforcement phase, that is secondary phase. So it is embedded phase, sometimes referred to as reinforcing agent, because it usually serves to strengthen the composites. So mainly the matrix phase, the examples for matrix phase is resins like epoxy, phenolic, etc. So mainly example for reinforcement phase is fibers, particles, or various other geometries. So mainly composites consist of two phases. One is matrix phase, another one is reinforcement phase. So first of all, we are going to see about the primary phase, that is matrix phase. So it provides the bulk from the part or product made of the composite material. It holds the embedded phase in place, usually enclosing and often concealing it. Then when a load is applied, the matrix shares the load with the secondary phase, in some cases deforming so that the stress is essentially borne by the reinforcement agent. Then reinforcement phase. So as I told, the reinforcement phase such as fibers, particles, and flakes. So main purpose of this phase is to reinforce the primary phase. So mainly factors in creating composites are matrix material, reinforcement material. So reinforcement, the factors of reinforcement materials are concentration, size, shape, distribution, and orientation. So this figure shows that how the reinforcement phase will embedded with matrix phase. So this is the dispersed phase, that is embedded phase. So this one is matrix phase. So matrix phase mainly such as resins. So the fibers will have layers by layers. So in between the two layers, the resins will be applied to stack together. So these images will indicate the different types of embedded phase with matrix phase. So it will have different shapes, different sizes, and different concentrations. So mainly, according to the uh, type of embedment, the composites are mainly classified into three. So mainly based on the type of reinforcement, first one is particle reinforced, fiber reinforced, then structural composites. So particle reinforced composites will be further classified into large particle, dispersion strengthened. Then fiber reinforcement composites will be further classified into continuous or discontinuous. The discontinuous fiber reinforced, that is FRP composites, will be further classified into aligned and randomly oriented. Mainly, the structural composites will be classified into two, that is laminates, then sandwich panels, that is honeycomb structures. So first we are going to see about the particulate reinforcement composites. The particulate reinforcement composites, the particles will be embedded with matrix phase. That is, particle size is 1 to 10 micrometer. Concentration usually ranges from 15 to 40% by volume. The particulate phase is harder and stiffer than the matrix. Mainly, the particulate composites examples are ceramics, tungsten carbide or titanium carbide, then vulcanized rubber with carbon black in rubber, then concrete. We well we well known about the concrete. The concrete is mixing with the sand and cement, sand and gravel particles in slurry of cement matrix. So these are all the examples of particulate composites. So particulate composites, another classification is dispersion strengthened composites. The examples for this dispersion strengthened composites are SAP, TD and nickel, copper and alumina, then copper, zinc and aluminum oxide. So mainly this dispersion strengthened composites having the volume fraction is 5 to 15%, and these particles are stronger than the pure metal matrix and can be metallic, intermetallic, non-metallic. So metal matrix composites will have the reinforcement phase and matrix phase, both are metal phases. But in the particulate composites, we'll have metallic or intermetallic or non-metallic. So matrix is the load bearing phase in case of this dispersion strengthened composites. So this image will be clearly indicate how the particles will be mixing with the reinforcement phase. That is, particles will mixing with matrix phase. So this is also will indicate the particulate composites. This is a filler composites. pillars as the reinforcement. Then second one is fiber reinforcement composites. This fiber reinforcement composites shortly called as FRP, that is fiber reinforcement plastics. So this FRP is mainly further classified into continuous and discontinuous. So this is the random fiber reinforcement composites. The fibers will be randomly dispersed with matrix. So this is random fiber reinforcement composites. So this is the long fiber reinforcement composites. So the fibers will having the long continuous fibers. So the fibers may be glass fiber or carbon fiber or aramid fiber, that is Kevlar fiber. So this diagram will indicate the different types of composites, that is different types of FRP, that is continuously reinforcement fiber composites. This is a discontinuously reinforcement fiber composites. This is the initial type, that is particulate reinforcement composites. So this one is third type, that is other composite structures, that is a laminar composite structures. Two or more layers bonded together in an integral piece. So example for this laminar composite structure is glass fiber composite, carbon fiber composite, or any other natural fiber composites or polymer composites. So this is the sandwich structure. So in the sandwich structure, the foam material, that is core materials will be in the center. Then the bottom and top of the foam materials will be covered by these layers, metal layer. It may be metal layers or polymer layers. So totally it is known as honeycomb structure. So it consists of a thick core of low density foam bonded on both faces to thin sheets of a different materials. So this is sandwich structure. So as I told, mainly the composite materials will be classified as polymer matrix composites, metal matrix composites, ceramic matrix composites. So according to the type of reinforcement, we already studied particulate composites, FRP composites, structural composites. This classification based on uh, different types of matrices. So mainly it will be classified into polymer matrix composites, metal matrix composites, ceramic matrix composites. So as I told, polymer matrix composites may be glass fiber, carbon fiber, or Kevlar fiber. Metal matrix composites may be aluminum copper metal matrix composites or copper diamond metal matrix composites, etc. So ceramic matrix composites, the examples are ceramics. It may be alumina or um, silicon carbide. So that type of ceramics will having consist of this ceramic matrix composites. So polymer matrix composites are further classified into thermoset plastics composites or thermoplastics composites or rubber composites. So in this metal matrix composites or polymer matrix composites, mainly the purpose of the matrix is to hold and bind the reinforcement phase in position within it, act as a medium through which the external load is transmitted and distributed to the reinforcement phase. It separates fibers from each other and it protects the individual fibers from surface damage due to abrasion and oxidation. Mainly, it will be improved fracture toughness of the composites, and it will have high resisting of electricity and control chemical attack. So polymer matrix composites advantages are it are more important than MMCs and CMCs because it will have lightweight and high strength and high stiffness. So mainly example for polymer matrix composites are rubber reinforcement with carbon black and fiber reinforcement plastics. So metal matrix composites. So metal matrix composites are both having metals. So and matrix faces phenolics, polyesters, and epoxies. So metal layers will be stacked together by means of these matrix faces like phenolics and polyesters and epoxies. So epoxy matrix phase is widely used for making the metal matrix um, uh, polymer matrix composites and or metal matrix composites. So mainly epoxies are widely used for polymer metal, that is FRP composites. FRP, that is fiber reinforcement plastics. So mostly phenolics, polyesters and epoxies are used for FRP composites. So as I told, the mainly polymer metal matrix composites are having glass fiber, carbon fiber, and Kevlar fiber. So mainly these type of glass fiber composites are used for making automobile and marine bodies, storage containers, plastic pipes, and industrial flooring. So carbon fiber composites. Carbon fiber composites are most harder than the glass fiber composites. So mainly advantages of carbon fiber composites are high specific strength and specific modulus, higher strength and elevated temperature, not affected by moisture or acids. So mainly carbon fiber reinforcement plastics are widely used for making aerospace application, sports and recreational equipments, and pressure vessels. Then aramid fiber, that is Kevlar or Nomex fibers. So these fibers are having advantages of high toughness and impact resistance, high resistance to creep and fatigue failure. Mainly the aramid fibers are widely used for making bulletproof vests and armor, sports goods and missile cases, pressure vessels, clutch linings, and gaskets, which are used for in automobile parts. Then metal matrix composites. Metal matrix composites, as I told, widely used for making metal matrix composites metals are aluminum, titanium, magnesium, and their alloys. So advantages of metal matrix composites are higher operating temperature, non-flammability, and creep resistance, greater resistance to degradation by organic fluids. So applications of metal matrix composites are aerospace application, gas turbine blades, electrical contacts. Then ceramic matrix composites. As I told, alumina, then stabilized zirconia are mainly used for making ceramic composites. So objective of making CMCs was to enhance the toughness while retaining the high temperature properties and high melting points and good resistance to oxidation, but low tensile strength, impact resistance, and shock resistance. These are all the limitations of CMCs. Then hybrid composites. Hybrid composites are having different types of fibers. That means glass and carbon fibers, and Kevlar and glass fibers. So the different types of glass fibers are, uh, polymer fibers are making hybrid composites. So mainly applications of hybrid composites are aircraft and aerospace applications, automotive applications, marine applications, sporting industries, biomaterials, and industrial applications. So this diagram will have the more applications of MMCs, that is metal matrix composites. So mainly the structural components of aircrafts like wing, fuselage, and these control devices like vertical stabilizer are making the thin of metal matrix composites. And also the nose of the aircraft, that is the front portion of the aircrafts are mainly covered by the metal matrix composite sheets. So these are all the applications of MMCs, that is metal matrix composites. So graphite, aluminum, metal matrix composites are used for making satellites, missiles, and helicopter structures. And boron and aluminum are boron, aluminum, magnesium, titanium. So mainly main content is boron, additional metal matrix component is aluminum, magnesium, and titanium. These metal matrix composites are used for making compressed blades and structural supports, antenna structures, jet engine fan blades. Then alumina and aluminum metal matrix composites, or alumina or lead, or alumina or magnesium. These metal matrix composites are used for making superconductor restraints in fission for power reactors, storage battery blades. Then helicopter spare parts. Helicopter parts are mainly making by using this alumina-aluminum combination of metal matrix composites. Then silicon carbide with aluminum or titanium or superalloy. These metal matrix composites are mainly used for making high temperature structures, high temperature engine components. Then the metal matrix composites, which consist of molybdenum, tungsten, and superalloy, will have high temperature engine components. So this is the engine head, that is the top of the engine parts are making by using the metal matrix composites like aluminum composites, aluminum and alumina composites. So applications of advanced composites, that is polymer metal matrix composites. This diagram will have the advantages of polymer metal matrix composites, that is fiberglass, graphite, and Kevlars. So mainly the nose of the aircraft, the outer skin of the wing, and outer skin of the control devices like rudder, elevator. These are all the control devices and spare parts of the aircraft, like wing and fuselage, are used for making this uh, glass fiber composites, uh, graphite fiber composites, and Kevlar fiber composites. So mainly control devices like ailerons, flap, and rudder elevators are mainly manufactured by using these uh, polymer composites. So in this diagram, the green color will indicate carbon aramid epoxy, that is carbon Kevlar epoxy composites. These composites are used for making the outer skin of the junction of fuselage and wing, then the edge of the wing, that is winglet of the aircraft. Then the red color will indicate Kevlar and foam honeycomb structure composites. These aramid foam core composites are used for making the vertical stabilizer of aircraft, that is tail unit of aircraft. Then the pink color will indicate carbon DuPont Nomex, that is aramid composites. These composites are mainly used for making the top of the outer skin of the wing. Then this yellow color will indicate the carbon epoxy composites. These carbon epoxy composites are mainly used for making the engine components, that is engine casing of the aircraft. Then this uh, carbon epoxy composites are also used for making the vertical stabilizer skin, that is rudder and elevators. Then this black color will indicate glass fiber reinforcement composites. Mainly these glass FRP composites are used for making the nose of the aircraft. So helicopter rotor blades are also used mainly made up of the polymer composites and also the natural fiber composites and foam filled core of spare and glass epoxy composites. So this images will indicate the aerospace parts and wing panel and automatic structures. These these parts are mainly made up of the polymer matrix and metal matrix composites. So the disadvantages and limitations of composites are mainly this type of composites are brittle materials. So even it will have more tensile strength, and it will be easily broken, and also it will not be able to recycling. So these are all the mainly disadvantages of composites. And main the disadvantage of composites are more costlier, that is more expensive. So far we have studied about the mainly the different types of composites based on the reinforcement, based on the matrix, and main disadvantages and of composites, advantages of composites, different applications of polymer matrix composites, metal matrix composites, and ceramic matrix composites. So thank you for your patient watching. Thank you, students. Thank you.
Thank you so much for watching the video. Make sure you've subscribed so that you can get the regular updates. Use the feedback ink in the description to get your certificate. Thank you.